Let's jump into loops. Of course, we talked about for loops, while, and all other kind of styles that we use in MATLAB to do loops. We will learn how to program determinate loops with the for and program indeterminate loops with the while. What's the difference between determinate and indeterminate loops? Determinate loops are loops we know how many times we're going to loop through. Like when we say for I equals 1 to 10, we know we're going to loop 10 times. While sometimes you say for I equals 1 to n, this indeterminate loop. You don't know when it's going to end. That's the main difference between both. Now, determinate repetition with for. When you have determinate repetition, that means number of repetition for the for loop is determined in advance, as we said. Then from your math class, you know the binomial coefficients. This is the form for the binomial coefficients. You have the n and r, and you replace the n and r based on those two values along the expression. As example, here we have 10 and 3, then you replace 10 factorial divided by, which is the r factorial, is in this case 3 factorial, by 7 factorial, which is the n minus r. So 10 minus 3 would be 7. So keep that in mind. Now for the update processes, there is many problems in engineering that needs modeling your process where the main variable will be repeated and updated over a period of time. Now here we have an example where I'm going to share the script for it with you. A can of orange juice. Of course, this example is serving the process. How does one variable change along the script? That's the whole point of update processes. Probably you remember some samples before where we had x changing from 1 to 2 to 3, either in for loops or in linear statements. So a can of orange juice at temperature 25 C, placed in the fridge. The ambient temperature F is 10 C. Now we want to find out how the temperature of the orange juice change over the period of time. Now to approach this kind of problem, you need to make the time into periods of small steps, and each of length dt, which is standing for delta t, which is the variant of time. Now if the initial temperature Ti, that would be the temperature at the beginning of step I, now we can use a model equation that we can get Ti plus 1 from Ti. Now take this equation as it is. Now what is the new temperature, Ti plus 1? That would equal Ti, the initial temperature, minus the constant K multiplied by dt, which is the variant of time, multiplied by Ti minus F, which is the ambient temperature. Ambient means room temperature or the temperature of the environment that you're in. Now, K again is a constant parameter depending on the insulating properties of the can of orange in this case. Now, the units are already chosen, that's as assumption, so that our time would be in minutes. Now, let me share with you this script. So the code is saying that K, which is the constant of our equation, 0.05, F, which is the ambient temperature, is 10. A would be, which is the start time, 0, and B, 100 as the end time. So from 0 to 100 minutes. Now you say time equals A, that will help you to initialize time. And T equals 25, that will help you to initialize the temperature. Then the function load train, that's going to give you a sound of a train. So that's fine. It's just an incentive in MATLAB. Now the temperature difference dt would equal your input. So you're going to tell him what's your temperature difference that you need. Then we have the output interval equals the input interval. And if the output interval divided by the variant of time not equal the value that's fixed of output interval divided by delta t, then make a sound. That's making MATLAB give you a sound. Then he will display for you the message output interval is not multiple of dt. Then you'll clear the screen and you make a certain formatting for the display. Then you try to display time and temperature in a style of a table. You will display all the variables in time and in t. Implemented our equation that we mentioned in the slides. And you said if the absolute value of the rem time is less than 1 to the by 10 to the power of minus 6, display the time and t and end. If we run that, he's gonna ask you what's your delta t. I would say 10. What's the output interval in minutes? I would say 100. Then he gave me 2 temperatures. If we run it again, I think we can give him delta t to be 5 and the output interval 25. So the whole point of this example, he's showing you that you can change the time value and the temperature value as needed. So in this case, we're able to create a table and you hear the train sound, which is cool. Okay, there you go. Okay. As long as he didn't hit the word clear, so the values are still there, but he cleared the command window for you to show you what he needs to show you, which is in this case time and temperature. So now we know we can create a table of outputs and allocate a value of a certain variable more than one time, which is this case the t and the word time. We had different values as time moves on. For those of you who didn't get the output, this is how the output will look like, and you will hear the sound of the train, so try it yourself. Now we need to have a couple of notes here. You notice the function rem. That's used to display the results every time which you have op-int function mentioned as a minute. Now when time is an integer multiple of op-int, it is remainder when divided by op-int should be 0. And while this is probably the most obvious way of writing the script, we cannot easily plot the graph of temperature against time this way, because time and t are scalars and repeatedly updated. So in this case, maybe you can think of a creative way how to plot time versus temperature if the values are changing. Can you do that? Maybe you can play with that on the side on your own time. A way I can see it is wait until the result is populated and get back point A from time and point B from temperature. So you draw temperature versus time as points. Now the indeterminate repetition with while, now we will get a guessing game that we're gonna build together. Now we need to think, MATLAB will think randomly an integer between 1 and 10. You're gonna use the function rand or random. Then you have to guess it. If you guess it too high, he's gonna show you too high. If you guess it too low, he's gonna tell you it's too low. And if you guess correct, you're gonna hear a sound or you can hear the word congratulations. Now, how does the coding plan look like? You generate random integer, I believe using the function rand. Then you ask the user for input or for guess. Now you say while guess is wrong, if guess is too low, you need to tell the user it is too low. Otherwise, you need to tell the user it is too high. Then you ask the user for a new guess, and whenever he hit the right number, you say congratulations or whatever way you want it, and you stop the program. So the author said matnum equals floor 10 multiplied by rand plus 1, which will give you random numbers from 1 to 10. But you can start to try x equals rand 1 to 10. And we'll do the same thing. Guess equals input. So you are making a variable called guess. Then what's inside that variable? You can call it guess, you can call it A, B, whatever you want. Input, then your guess please between quotations. So you're going to give him a message, and at the same time, you get that value to be saved inside that variable. And forget about load splat, that's for the sounds that you heard. So while guess not equal to x, in my case, provide that sound you just heard. If guess greater than x, display too high, else display too low, and then if it's wrong, then you can ask him for another guess, which is guess equal input. Then you end it, of course, then you display, if he got the right number, you display that and you play a sound. That's the whole point. But if you want to follow the textbook code, he said matnum equals floor, then instead of x, forget about this x rand. So if you do that, instead of x, have here as matnum. That's exactly the code from the author. What else? Yeah, that's it. So let me try to run the code. Now I run the code, and you run it. Enter your guess, please. I would say 10. I would say 10. He said too high. So 10 is too high. I can say 2. He said too low. Then should it be 5? That's too low. 6. Too low. 7 is the right number. I don't know. I don't know where it came from. It's a fun program to play with. And those sound effects are never been boring. So again, matnum in this case equal floor gave you straight numbers. Instead of having the rand function, will give you points. Now we got somebody making it work. And yeah, it's just a while and if, as easy as that, with some spices with those numbers. Now, we already talked about the while statement, how it looked like. So you have while condition statement, then end. And the way you write it in a one-line MATLAB, while condition, space, statement, comma, end. And for the while statement, if we have doubling time of an investment, today is all about examples. Let's assume we have invested some money which draws 10% interest per year compounded. We would like to know how long it takes for the investment to double, and we want a statement of the account each year until the balance is doubled. Now, the statement of the problem is indeterminate loop with the structure plan we see here. First, you initialize the balance, the year, and the interest rate. Then you display the headings, what you need things to show up before the numbers, as we saw in time and temperature, right? Then display the headings, then you repeat. Then you update the balance according to the interest rate. Then you display the year and balance until the balance exceeds twice the original balance, and you stop. Let me share that with you. Okay. Now it looks good, we can run it. Okay, so it seems like everybody got it running. You get the year versus what's the balance, and whenever the balance is double the initial balance, he gonna stop. That's the whole point of this program. A number is prime if it is not an exact multiple of any other number except itself and 1. If it has no factors except itself and 1, then it's a prime number. The easiest plan here, that we suppose P is the number to be tested, and see any number n that can be found, then divide it into P without remainder. If there is none, P is a prime. And the structure plan for this program is input P, initialize n to 3, find remainder r when P is divided by n, while r not equal to 0 and n less than the square root of P. Repeat, increase n by 2, find r when P is divided by n. If r not equal to 0, then P is prime, else P would not be prime. Okay, now we have another one, projectile trajectory. We would like to know when and where the ball will hit the ground. This problem can be solved in a determinate loop as we discussed in previous chapters. We need also to see how to solve it with an indeterminate while loop. Now, to calculate the trajectory, you need to calculate the trajectory repeatedly with increasing the time, while the vertical displacement y remains positive, and the script should look like this. So you got delta t, you got g, you got u, then you input your angle. If you run it, what you're gonna get is, let's clear and run it. Launch angle 45. Okay. Then he gonna give you displaying here the time, then the x and the y. So time, x and y in 3 columns. Then you can see the function more. You see here more 15. That will give you more lines to display in case the data is too big. It's just a better way to display the data conveniently in the command window. If I hit enter on it, he's gonna give me more lines and more up to 15 lines that are added to the initial values that we got. Okay, I believe most of you run it. So now we'll talk about break and continue. As you're talking about while, you're talking about break. Break will terminate the execution for the while loop or the for loop. A break statement exits for or while loop completely. To skip next iteration and begin the next iteration, you can use continue. So as you can see here, we have the limit equals s equals 0 while 1. Temperature would be random. Now if temperature greater than the limit, break, that's gonna stop the while loop and continue in the code s equals s plus temperature and repeat. Then if you hit continue, he gonna, in this case, will begin with the next iteration. So he's gonna skip whatever f is doing and go right away to the next iteration, which is like if n was 1 in this case, continue will go to n equal 2. If it was 2, he will continue, go to n equal 3, and so on. That's a way to skip a while or a for loop, either skip backward or skip forward. So break will skip backward, he will break the link. You'll be able to exit that loop and do whatever happening after that in terms of statements. Continue will kind of reset the for loop. If it was n equals 2, he's gonna go back to the next one and skip whatever after that. So the priority here for the next n, not for the statement, while for the break, the next priority is for the next statement. That's all about break and continue. One cool way is menus. MATLAB, of course, there is a graphical user interface for MATLAB that's very helpful. A sophisticated application where you can have a user interface like an app style on your phone, but to be used on any computer that have MATLAB installed on it. Now we will try to create a simple menu. I believe you're gonna find it cool, and you can run it on your machine. So you have key, you have while, but when you write the word menu, you are able to create a menu that will show up in front of the user, and he will be able to choose from it. To get menu, just run the code, and he's gonna show me a menu. You can, of course, it's just general menu. You can say do this, do that, or quit. So that's cool. You can say create a green letter, I mean a green color, or red color, or blue color by menus. You can, maybe you can create a whole exam just based on a MATLAB code if you are crazy enough to do that. So there's many ways to find this helpful. Go ahead, make sure you can run that menu. And I encourage you in your own time to play with it. Try to make that menu more meaningful. And I think you can do a lot of cool stuff with it.